I'll say a bit more about the company in a moment, but in terms of myself, I'm an architectural technologist by training. So yeah, I always had a sort of an interest in buildings from a technical perspective, how they go together, how they work. And then yeah, bitten by the bug of all things building performance measurement very early on in my career, and so I've done nothing but measure buildings since. Um, so yeah, quite a big topic, building performance evaluation, measuring, monitoring. So let's yeah see how we go. Like Simon said, please do just put questions in the chat as we go. I'd rather not just talk at you for 45 minutes flat out. Please, if you ask questions, Simon can interrupt me and we can talk about any specific slides that trigger questions or further thoughts. So let's try and have it as a bit more of a discussion. In terms of what we're going to try and cover then this afternoon, so what is building performance measurement? So there's lots of terms and acronyms bandied around, so we'll cover a bit of that. We'll really get into why measurement's important. Some of it's fairly obvious, but we'll really try to look into that. And then what's the relevant regulations and standards that apply in this area, what's coming down the track. And then we'll spend a little bit of time on available technologies and methods, and then some case studies at the end. And the adage we're forever driving at, you can't manage what you don't measure, of course. Okay, so in terms of just a quick word on build test solutions, we established ourselves in 2016, and our mission as a company is to make measurement mainstream. So we're really trying to challenge the status quo around both how we're assessing existing buildings. So yeah, it's one thing to do EPCs and energy audits based on visual inspection, but actually how do we embed sort of measurement into those processes? And then yeah, again, how do you also measure and verify new build homes and non-residential buildings as well, of course, to make sure that they do what they say on the tin. Myself and a lot in the team, we first came across building performance measurement through programs like Innovate UK Retrofit for the Future and Innovate UK Building Performance Evaluation Program. And yeah, going back kind of 10, 15 years or so, the only real actors in the building performance evaluation space were largely universities. So it was quite an academic subject matter. PhD, master's students doing things like co-heating tests on buildings, tracer gas decay testing, using lots of expensive instrumentation to do really forensic kind of investigations on buildings. All really interesting, but you would see projects spending 15, 20,000 pounds sort of monitoring just one building. And that, don't get me wrong, throws up lots of insights and has its value, but clearly that's not a particularly scalable exercise. So yeah, we've been, since our formation, working closely with a lot of leading universities, working to discover alternative methods, really challenging those established academic incumbent techniques, and trying to develop tools and techniques that are much more accessible and affordable for industry to adopt and yeah, apply at large. So it's about bridging this technology valley of death and taking ideas and concepts from universities and developing tools and techniques that can be taken into the mainstream. Okay, so what is building performance measurement? I'm going to start with my 3M slide. So modeling, measurement, monitoring, I think are three really important terms for us to look at and kind of acknowledge the difference between them. So modeling is many of you will be familiar with sort of yeah, producing model simulations of buildings, but it's yeah, typically input parameters that are either defined by product libraries or manufacturer supplied information, or lookup tables in things like CIBSE uh, guidance documents, or in the case of SAPs, or lots of sort of look up parameters based on previous studies and things. But yeah, predominantly input parameters divided by desktop exercises, visual inspection, to create a model or simulation of a building. So we've got at the lowest level kind of RD SAP, lots of lookups, they're designed to be low cost, non-invasive, that carried out at scale. But yeah, lots of interpretation, interpolation, sorry, and inference of the U value must be this based on the age and construction of the building kind of thing. SAP, where you've got a bit more flexibility to input different parameters. PHPP, still a static simulation model, but again, a bit more flexibility in what you can input. Lots of discussion at the moment around a home energy model. And then you've got at the other end of the spectrum, kind of full scale dynamic simulation models that kind of, 1 minute kind of high resolution kind of weather tape simulations and things. But all of that, there's nothing wrong with any of those modeling tools. They all have their place, but they're highly susceptible to garbage in, garbage out. If you put incorrect assumptions into that model, then you're going to get not so helpful outputs from it. And there's limits to them, especially when we're assessing existing buildings, limits to kind of how much you can really have confidence in the inputs based on just visual inspections and historic kind of lookup tables. So then we get on to our good friend measurement. And so this would be on-site based physical testing of physical characteristics of a building at a given point in time. We're going to talk a lot about this, so I won't labor it too much, but things like measuring the heat transfer coefficient of the building. So what's its energy balance? How well does the building fabric retain heat? Air tightness, which many of you be familiar with, how leaky is the building? U values, you can measure the specific heat transfer rate through floors, walls, ceilings at a given point in time. You can measure ventilation flow rates, so how much airflow is being delivered by that fan, given its ducting and configuration. So we can measure things on site. You can also, mostly, obviously we're talking about energy performance model measuring, but you can also, of course, measure things like acoustics on site, and you can measure uh, material densities and materials, structural properties of materials, of course, as well. But yeah, you can go on site and you can measure stuff. And then we've got monitoring, and these measurement and monitoring are often kind of intertwined, but I think it's important to make the distinction. Monitoring is something that would be more of a longitudinal exercise. So you put sensors, typically environmental condition sensors, temperature, humidity, CO2, and you would monitor the conditions over a duration. You can monitor energy consumption, you can monitor heat metering, heat outputs, but yeah, over a period of time, and then it's sort of down to you as to then what you might want to do with that longer term monitoring and kind of how you might use it. But yeah, three really important sort of M words there: modeling, measurement, and monitoring. And then I'm sure you're all as interested as me in ensuring that we're delivering buildings that perform in reality. None of us have any intent to just deliver the best building since sliced bread in theory or on paper. We can all kind of manipulate models and make something look more impressive than it might actually be. But clearly, if we're taking net zero seriously and want to actually build and deliver and retrofit good quality buildings, then it's important that we're doing that in a way that actually delivers in reality. So yeah, what we're driving at is outcomes based assessment of buildings. And so some of the common practices you've got, widely practiced would be visual inspection. Happens a lot. So thinking about the delivery of a new build, there are building control will drop in on the building at certain points to visually inspect and sign off at key stages, sign off at the end. Building control officer's not doing any testing or checking. They're looking at documentation and they're visually checking what's being done on site. So okay for the quality control process and sign off, but again, no measurement there. Energy performance certificates. sort of interesting, give people ratings, but again, it's not really a representation of the actual performance of the building in any way. Smart metering is quite interesting. Obviously, again, thinking of it as a monitoring endeavor, look at how much is being consumed over the course of a year, and then you've got headline energy use and what the occupant spending on that energy. Um, you've got increasing adoption of Internet of Things, kind of low cost sensors, gateways that can go into homes. Even like things like smart thermostats and home energy management systems can continually monitor environmental conditions. You're seeing a lot of this in social housing in particular at the moment. So um, housing providers, whilst they might have ordinarily just had an asset management register and stock condition reports and in sample-based testing, some EPC records, they're increasingly putting sensors in homes, and they can see they'll be getting warnings and flags based on this property is excessively cold, or it's been sustained high temperature for a long period of time this summer, or that kind of thing. And then occupant evaluation surveys. You can gauge sort of occupant satisfaction. So there's a few things there, but it's like, and they're all interesting in their own right. But it's worth stopping and thinking about, well, actually, which of those are helping me to make sure that the buildings I'm involved in and delivering are actually performing as I expect them to? Why am I using those metrics in particular? And yeah, how many of those are actually smart in terms of specific, measurable, achievable, realistic, time bound? Some of them are quite qualitative and difficult to necessarily apply consistently across projects. And just the image to the right there, clearly it's quite a complicated space. You've got the fabric itself, you've got the systems operating within that fabric, you've got people and all their behavioral traits, and their behavioral sort of energy use behaviors, and then the environment and all the variables of weather, all influencing that bullet pointed list. Um, so at Build Solutions, we've focused a lot of our efforts on developing tools for measuring specifically the fabric. I refer to this as sort of control the controllables. If we can measure and verify that the building fabric performs as intended, then actually everything follows quite nicely from there in terms of, yeah, if the fabric is of a known standard and quality, then the heating system that was designed for that fabric should be able to deliver that peak heat demand and operate efficiently as intended. The ventilation systems will be designed in accordance with the air tightness, and should balance nicely and work efficiently. And then occupants, frankly, should be able to live in and operate their homes as they see fit. Yes, you can always do sort of behavioral nudges and things, but again, if the fabric's very efficient, then I think the people aspect is less of a concern. I know people get really interested in measuring occupancy factors, window opening behaviors, and all of this kind of stuff. And it's like, well, that's interesting, but what are you going to do with that data? You know, necessarily tell occupants to behave differently. And again, if your fabric performs, then you should be well protected from the surrounding environment. So again, we'll come on to this in a bit more detail, but talking about measuring the heat loss rate of the building, the heat transfer coefficient, its air tightness, whether that's with pulse or blower door, and technique, U values, whether that's heat flux plates, or again, something we've developed here at BTS is what are called Heat 3D. And then you can also, from some of those bits of insight, you can also determine kind of mold and overheating risk. You measure ventilation flow rates. So just to, yeah, hammer home that point, I think we're all interested in delivering low energy, low CO2 emission, low running cost buildings, but those things are actually really difficult to measure. They take a long time to kind of prove out. So actually, we think measuring the absolutes around the fabric performance is a much more sensible way of going about things. And if all of those perform as designed and to spec, then low energy buildings naturally follow. Um, and so when you look at any kind of, this is an excerpt from SAP, but you look at any uh, building performance simulation tool or modeling tool, um, they all have a means of calculating the thermal performance of the building, and this is just a screen grab to show kind of and what's driving that. So you've got all your inputted U values, the respective area that each of those elements represents. You're adding in your thermal bridging. You've got an infiltration and ventilation element to it, and then you're arriving at what I've touched on just now, the HTC, the heat transfer coefficient. So yeah, all these are particularly key parameters around influencing, driving what the resultant kind of thermal performance of the building might be. And we're simply saying measure those aspects. You hear lots of people talk about, well, no, I'm actually motivated by space heating demand, kilowatt hours per meter squared, and I'm interested in the absolute running costs. These are just a couple of charts to show that actually a measured HTC, the measured pure fabric performance, directly tracks to these things. So here on the left-hand side, we've got HTC reducing in a linear fashion with space heat demand. So no surprises there that you improve the fabric performance, your space heat demand comes down. Similarly, lower HTC deliver better EPC ratings. So whilst space heat demand again might be a desired outcome, it's quite a hard thing to measure because you've got, well, how much energy is an occupant put into the home? Is it an energy use behavioral thing that's driving the high space heating consumption, or is it the poor performing fabric thing? So by measuring the fabric and the HTC, it's just a much more accessible way of testing and validating a building. And then just a couple of sort of examples of this in practice then. So here's a 1930s sort of interwar estate, maybe a bit later than that, 35, something like that. Southeast London, visually very similar properties, semi-detached. You walk down the street, you'll think they're very much the same. Broadly, very similar EPC ratings, or circa kind of D. But you measure the heat loss rate of those buildings, the heat transfer coefficient, and you see this level of variability. So some are it's like a 40% higher heat loss, some 37% less. And then quite interesting, on average across the 10, this is comparison, the difference between predicted heat loss by EPC assessment versus measured. So actually, on average across the 10 homes, as I say, the EPC has broadly represented the properties on average within 1%, but it's not been able to recognise and reflect the nuance of each individual home. And so, I don't know, a higher heat loss might be actually you go up into the loft and the loft insulation isn't run all the way back to the wall plates, or window units might have failed. So they might all look like they've got double glazing, but those frames or glazing units have let go. So yeah, these buildings are very old, so they've all settled and been knocked about and modified ever so slightly differently in different ways. Air tightness is hugely variable between them, for instance. And then exactly the same kind of image here. This is 20 flats in a low-rise block in London. Again, EPC predicted performance versus measured actual. And this is just measured heat loss rates and nothing to do with occupancy or weather. It's just how well does the building fabric retain heat. And again, so you're seeing really big swings between what you might expect to be very similar properties, all constructed the same way, of course. Yes, you've got some ground floor, mid floor, top floor, but again, it's this thing, you can't manage what you don't measure. It's really surprising sometimes when you measure these properties, they can perform very differently. These are two existing building examples. We see exactly the same with new build. So you think a whole new build estate has been designed to a given spec. It's not unusual at all to measure a bunch of properties all completed within the space of a few weeks on the same street, and the deviation from the design intent is enormous, plus minus 100% on them. And it's like there's quality control issues, workmanship, there's product specification, product substitution issues, there's just like buildability issues around sort of how possible is it to, how consistently can we implement certain building details. Just so many different factors that are at play influencing the end performance of the building. And
Look, when you
yeah,
do that, are they, for instance, those are new builds, are they social housing or as a private developer housing?
I
Or
wouldn't even pigeonhole it to one
property?
particular area. Like we've measured really high end, sort of low energy new buildings. But the building performance evaluation program is a great example. That was Innovate UK run initiative. I think it was about 120 properties. It was developers putting themselves forward with research teams to have their new build schemes measured. They were getting funding for it through Innovate UK, and they knew they were actively involved in an evaluation program. And even though they knew they were being measured and evaluated very publicly, they would, and it was a real mix, some low energy schemes, some quite standard major sort of national house builder type schemes. And again, it was you just throwing up this huge variation in performance. So I wouldn't pigeonhole it to one particular tenure
No,
or
I just
say.
wondered what they do with that information then. So,
Mhm.
I mean, it just goes to show that the mean, well, I'm not a mathematician, but in this instance, the mean doesn't really mean anything, does it? Because the variation is bonkers. So when you are modeling, because if you said right from the start that not modeling when you're measuring, right from the start, because everything can be different regardless of how you're making assumptions that the buildings are similar in their
Mm.
performance. But these guys that were part of that Innovate UK scheme then or campaign, when these numbers were presented back, did they do anything with it? What was
There was
what
certainly,
there?
yeah, a lot of reporting went on, I can't speak for individual project
No,
participants and what they did in terms of implementing changes, but it's back to that you can't manage what you don't measure
yeah,
adage, and our mission of making measurement mainstream is because of this. It's
yeah,
because unless it's more widely practiced, it's my technical director describes it as Pandora's box. Sometimes it's like it's almost just as um, tempting to not open this can of worms and
sure,
like carry on as we
yeah,
we were. Um, the models are yeah they're instructing us towards these designs, and let's leave it sort of
yeah.
as is. Whereas yeah, I think if as these new tools and techniques become available for that make measurement that much more accessible, we're no longer measuring really small numbers, one-off buildings. It's like measurement just becomes so much more commonplace. You then start to be able to learn as to what works well and not so well, and
Hmm.
create that feedback loop in the very kind of genuine sense of the word. And it's like I said, it's multifaceted. So yeah, it's not to point fingers and say product manufacturers' performance claims are nonsense. No product performs like manufacturers say they do, or it's not. It's always the operative on site delivering a shoddy job. It's a multitude of factors, and some of it's really basic as well. Like new build homes, identify a performance gap, and then go back to inspect, and it's because a plumber or an electrician has been up in the loft and moved all the loft insulation around to get access to some services and not put it back. And so it's like that's a 5 minute fix. Just relay the loft insulation properly, and maybe even like visual inspection would have identified that in some cases. It's a very simple example, but um, yeah, it's most definitely not us saying measure stuff and if it doesn't perform, knock it down and start again. Or it's like just only by measuring do we learn and inform future projects and things. But yeah, good question. And then this is just zooming out even a bigger macro scale. We were sponsored by DESNZ alongside the Energy Saving Trust to run this assessment of, okay, looking at a bigger sample of homes, how different are SAP heat loss predictions versus measured actual. So this is 500 properties. And again, here you can see that the predictions are good on average. So if predicted heat loss and measured heat loss agreed exactly, they would all follow this solid black line. The trend line through it is actually this dotted line. So you can see that broadly the tools are there or thereabouts. But yeah, not very many were. You can see half my slide for the participant dialogue, but yeah, there you can see that there's huge swings on either way. So again, it's kind of recognizing the nuance of each individual home is where the modeling falls down, and that'll be whether it's you can see here. So I guess some of the agreements may be a bit better down at the lower end, sort of lower heat loss, better performing buildings. But again, you've still got some that are more than twice. This dot up here, kind of 3 times nearly the heat loss of the predicted. So it's like, yeah, measurement really helps identify these outliers and the problem homes, and I guess also prevents if you were to measure some of these homes early on, prevents kind of issues manifesting for a long period of time or lots of disputes that end up really protracted. So you can measure a HTC in the space of 3 weeks. And then you've got to the nub of, okay, the building fabric either does or doesn't perform, what we're going to do about it. So yeah, you can see here, again, it's quite an interesting study that just shows the difference between predicted and then measured heat loss. I won't labour this too much, but very similar story, air tightness. This is just an extract from our data set. We're sat on about 70,000 or so pulse air tightness tests, mostly existing buildings actually. This is a subset of 13,000 of those. You can see that the mean air permeability is talking 50 Pascal language, 8.7 meters cube per hour per square meter of envelope area. And RDSAP is predicting that, or makes the assumption that air leakage is in the order of 10 to 15. So existing buildings are actually, again, on average here from this sample, this distribution, much more airtight than SAP would have us believe. And again, you can see that there are some that are really airtight. There are others that are even more leaky. And so again, if you don't measure, you can't possibly know where your building sits on that spectrum. Obviously, new builds a bit different. Air tightness testing is mandated at the handover stage, but I've got a little slide on that in a moment separately. And then same story with U values. So we assume solid walls, for instance, to have a U value, I think it's of 1.8 in RDSAP at the moment. And this is the deviation from that. So some are U value of 0.6 lower than that, some up to 2.2 more than that. So you've got this huge range of variation in what the actual U value could be for something as simple as a solid brick wall. So then it's really important to stress then we're not saying EPCs are crap, energy modeling has no place, throw it all in the bin, start again, measure everything, incur lots of cost and complexity. It's just all we're saying is garbage in, garbage out. Measurement and modeling can live in harmony, and we can measure parameters and then input those into our models to better calibrate them and make them more yeah, more accurate, more instructive in terms of investment decision making, or yeah, checking that the building, if it's post completion, is actually doing what we expect it to do. I And so fairly obviously unexpected performance means unintended consequences. So if you've got if you've measured the building fabric of a property and it's higher than what you might expect, you're going to have higher energy consumption, poor thermal comfort, difficulty to maintain stable conditions, overheating risks, those kind of things. You're going to have ventilation challenges, damp and mold issues are going to maybe be more prevalent. You've got just general quality control issues. Um, and so by measuring, we can better target and prioritize retrofit activity. We can inform retrofit design and specifications. We can quality check and verify as-built performance of both retrofits and new builds. And like we've just touched on, get feedback and inform future projects. So I'm going at a rate of knots here, but we've got quite a lot to cover. Um, so like I've said, yeah, if, is this perhaps Pandora's box? Why doesn't everyone measure already? This is just the boot of the car of, again, one of my colleagues previously out doing sort of the academic kind of co-heating tests. Loads of bloody fans and heaters and all this proprietary equipment needed to do testing, and often sort of those academic incumbent methods require properties to be vacant and under lock and key for 2 weeks at a time. So yeah, old methods were sort of prohibitively expensive and invasive and not very practical. And so that's what we're really trying to challenge, is that, well, does it need to cost the earth and be that difficult to really measure and understand some of the key performance parameters? And just last one on this sort of introductory section is that I think we should also acknowledge that we want to measure for the right reasons. This was a study by Jenny Love at UCL a few years back now, where they analysed air tightness compliance test databases and found that there was this not so normal looking distribution on results. So, for instance, where the target air permeability was 3, you were having this kind of cliff edge, sort of, yeah, a bit alarming. For why is nothing worse than 3 for this compliance test? And so what we don't want to see is advocate measurement at large, but then people just seek to game it or yeah, manipulate test results or yeah, alter the building until they get the right answer, kind of thing. It's, again, it's, we want to be measuring for the right reason to serve, yeah, not beat ourselves up and say, oh, isn't it a shame we're not delivering buildings as intended? It's, we're, measurement hasn't been a widely spread practice, so we want to sort of support one another in the industry, support contractors, support those on site, support manufacturers. Why is this building not performing as we thought it might? What can we do differently? How do we revise the details and practices on site to make sure that we are delivering truly net zero buildings? Some not so exciting slides now, but I think it's important we did look. These are a bit wordy, but just look at some relevant policy and regulations. So I'll canter through these, but again, I think a recording will be shared afterwards, and I can certainly make the slides available as well if this area is of interest. So, building performance evaluation in current policy and regulations. So we've got obviously Part L mandates 100% of new build homes must be air tightness tested. So that's driving an air tightness industry already in this country. We've got PAS 2035, the latest version is 2023, and that is also requiring pre and post air tightness testing of existing homes. So that's a really big growth area for us in particular, we're selling a lot of pulse equipment into that space. Pulse being quite a nice non-invasive way of testing existing homes, a bit less disruptive than bolting a fan on someone's front door. There's also then a dedicated section 13 within that document that talks about the requirements of doing monitoring and evaluation on projects. Again, just trying to encourage project teams to go back and assess what was actually delivered. Does it perform as intended? What can we learn from that? Trustmark aren't beating people up on whether it does or doesn't perform. It's just then trying to encourage that learning and feedback cycle. And then Annex C of that same document introduces this concept of background ventilation testing. So assessing the level of yeah, background infiltration to then determine whether it's appropriate to be necessarily adding more trickle vents and passive vents into what's already a fairly leaky home. Um, some really interesting stuff going on in planning policy. So certainly those that I'm aware of, I know there are others, but Milton Keynes, the GLA in London, East Hants District Council, all have mechanisms within their local planning policy to say that you've got to measure and monitor a sample of plots. Milton Keynes goes so far as I think it's 10% of properties on a given scheme need to be tested and then monitored for a period of 5 years post completion. So that's planning policy mandating this stuff. SHDF's been in the news this week. That heavily encourages monitoring, testing, some nice bonus points available under the innovation kind of categories there. We don't see a huge amount of this, but there's definitely a market in and around expert witness, CPR 35 reports. So again, it's helping with that dispute resolution, getting to the bottom of sort of root cause effects of issues. Maybe it's a heat pump that's not working or delivering desired comfort levels, but it's not strictly the heat pump's fault. It's that the fabric's got a higher heat loss rate than was anticipated. So there's definitely a role for expert witness services in and around all of that. Part F requires ventilation inspection, commissioning, testing, and that's something that government are really trying to make sure is happening more often than has previously been the case. And then you've got some sort of in-use verification mechanism in Part O around overheating, but not particularly widely practiced. But you could imagine that kind of space evolving further. Then loads going on in voluntary standards. So some of you may have come across BS 40101, a British standard written just a couple of years ago that really tries to better define building performance evaluation and set out a framework. So it describes kind of preliminary, light, standard, and investigative levels of building performance evaluation. So you might start to see clients writing that into specifications and procurement standards, even though it's not being mandated anywhere. It could kind of trickle in as a voluntary thing. HAS 2035, the evaluation section references that standard as well, for instance. Many of you on this call will be familiar with Passive House and Enefit and how that has certain stage gate reviews and not strictly a huge amount of measurement stuff, but yeah, definitely that interim air tightness testing and sort of there's some added depth to that. Elmhurst have recently launched what they term their measured energy performance scheme. So again, it's all voluntary at the moment, but you can become with them a certified measured energy performance professional. And they've got quite a neat feature of their SAP 11 software where you can toggle the measured HTC into the SAP model. So you can't use that to generate a compliance EPC, but you can see what impact it has on the EPC rating and the running costs and all of this kind of stuff. So you could imagine a whole service offering around I'm MEP qualified and I can do heat loss measurements and I can tell you the implications on your running costs and CO2 emissions. Full SAP obviously offers lots of flexibility to input more detail around, you can do thermal bridging modeling and stuff, but you can also input measured U values, measured air tightness. Energy Sprong is quite an interesting space. They've obviously got a building performance clause in the whole kind of delivery concept. So Energy Sprong projects are where we see a lot of our kit used to be doing measurements as well. Soft landings is kind of another one in the non-domestic space, again voluntary, but often crops up through procurement channels and things. I've never seen the IPMVP protocols practiced in the UK, but something to look at if you may be interested. ACB Carbon Light, I must admit I don't know what measurements in there, but again it's I guess similar in many ways to Passive House Enefit, trying to encourage stage gate reviews and things. Home Quality Mark talks about monitoring and measurement quite a lot. Don't see it widely prescribed, but it's definitely in there. BREEAM in use would be another. We're also seeing a lot of at least a couple of the big insulation manufacturers developing measurement techniques of their own so that they can offer performance guarantees around the product. So specify such and such insulation, and we will guarantee that it performs. And we've got our own measurement techniques that will help prove that is the case. So that's another interesting thing. It's not being driven by regulations, but it's driven by the manufacturers wanting to showcase that their products do what they say on the tin. And then some stuff coming down the track. You've got eco pay for performance has been talked about by DESNZ for the last 18 months or so. Um, so a component of the energy company obligation in the fullness of time will be based on measured performance rather than you get your lifetime fuel bill savings from the eco based on modeled assumed kind of impact. You'll actually measure the before and after. So that's going to encourage better quality retrofit delivery so that you can eke out the maximum from the works that you've delivered. And yeah, we're pushing for RDSAP the new RDSAP 10 due soon. It's been very delayed this year, but it's going to permit the input of air tightness test results for the first time. And we're pushing for more formal recognition of the ability to input U values into measured U values into RDSAP. MCS are on the cusp of releasing a new heat loss calculator tool. So MCS standards require that you do a heat loss calculation on a building to size the heat pump. Their new heat loss calculation software is going to permit the input of measured HTC, U values, and air tightness parameters. So again, that's kind of quite a soft market mechanism that's going to drive and encourage more measurements. And then your guess is as good as mine as to where we are with the Future Home Standard, but the consultation certainly referred to sample-based as-built testing. But when that comes in, what that will look like, I don't know, but again, it's one to watch. And then, yeah, more kind of blue sky thinking here, just BPE in the future. You could imagine, I know property passports gets bandied around a lot, but people with a much more comprehensive digital record of their home with measured parameters fed by smart meters and smart thermostats that are already in someone's property. You could imagine green finance starting to be more explicitly linked to measured performance. So yes, you can borrow £10,000 to apply insulation to your building, but I want the carbon credit from it. So tell me exactly how much the £10,000 spend on your property has delivered. Wishful thinking, but rather than design-based regulations, we could end up in a world of outcomes-based regulations. Compliance and sign-off may well in the distant future be based on the measured actual performance rather than just an as-built revised kind of SAP calc. And yeah, almost similar to the first point, really, we've got a lot of this tech in our homes already, in home displays, smart meter, home energy management systems, thermostats and things that are going to make measured insight into people's homes ever more accessible.
Sorry, Luke, I'm just
Yeah,
conscious of the time. We're
yeah,
going to come up to 1 o'clock soon. Where's a hard
yeah,
cut off? So yeah, if we can.
sure. Nearly there. I won't labour available tools and I'll just race through this. So we generally advocate, we've got a handbook on our website, Building Performance Measurement Handbook, that talks about a sort of approaching measurement in a sort of triage way. So measure the overall heat loss rate, the HTC, issue occupancy surveys, and then use that as a basis to then inform how you might delve into more in-depth measurements on a subsample of properties. So depending on what the HTC tells you will then trigger whether you do further air tightness testing or evaluation around yeah, ventilation and that kind of thing. Or if you wanted to dig down even further and kind of diagnose the issue at an element level, you can measure U values and do thermography. So we try to put a bit of a framework around, we're not saying measure all things all the time in every building. It's there's kind of, we can apply some kind of triaging and intelligence to the process. So like I said, focus in particular on measuring the fabric performance. Some of what we do is here on this slide, but like I said, we've got Pulse as a compressed air-based method of measuring air tightness. There's absolutely the blower door technique as well. To complement pulse, we've got leak checker, which can help site teams do diagnostics through the build phase, so that there's no surprises when it comes to the compliance air tightness test. Smart HTC is our answer to measuring HTC in a building. Like I say, it's very simply 3 weeks worth of internal temperature data and total energy consumption needed to drive that algorithm. So it's really not an expensive or invasive undertaking. And there are a couple of different ways of doing U values. We've got Heat 3D, which is a thermography based technique that's pretty neat. Happy to talk to people offline about that. But there are also heat flux plates, which are quite versatile in terms of being able to measure window U values and slope ceilings and things like that. So yeah, happy to talk to people about some of these in more detail offline. Then yeah, I won't I think we're running out of time now, but this example I showed earlier, the story block of flats, it was actually the mid-floor flat that had the biggest performance gap, and it was because of this huge thermal bridge, this exposed balcony. Again, measurement has been able to expose that and inform the retrofit accordingly. This is an example, just a one-off property, but we've seen it countless times. Measuring the heat loss has determined that actually it's nothing like what was calculated, and you can have a far smaller heat pump. You don't necessarily need to bring in three-phase connections. In this case, it was a ground source heat pump, so it was one less borehole. So yes, the measurement up front has cost a little bit extra, but you've saved huge amounts on the capital costs and the disruption and the viability of the project as a whole. Again, I touched on with the background ventilation testing or air tightness testing, using that to inform the ventilation strategy of buildings is a really common activity at the moment, and rightly so. And this is an example of a flint wall in Norfolk. RDSAT would have assumed it to be a U value of 2.4. We've measured it and it's 1.2. And so you think about the conservation implications of that. Like, actually, we don't need at 1.2 marginal gains in applying any insulation, even if it was internal and not kind of affecting the outward appearance of the building. I think at 1.2, you'd probably just leave the walls as they are and focus your efforts elsewhere. So again, measurements informing your decision making in a much better way than just using a lookup table and just assuming taking it as read. So just final slide, we should remain resolutely focused on the real world impacts of buildings, not get too wed to our predictions and our models. No two buildings are the same and things are never as they seem. And so yeah, measurements are a natural extension to existing surveying practices. Only by measuring and inputting those parameters into our models can we better calibrate them, be in a much more informed position. Control the controllables around measuring and understanding the fabric in particular. I haven't talked so much about monitoring today, but I guess like smart HTC is a 3 week stint of monitoring. So I would describe that as sort of, yeah, it's a defined fixed period. Yes, you could monitor temperatures continuously, but it's kind of, I'd encourage you to stop and think about that and what you're doing with that data. Is anyone actually looking at it and
So that is interesting. So what are people doing over 3 weeks? You get the results,
yeah.
and then who's asked for it? Is the homeowner involved as such? And then what do they then decide to do? Is a report sent out that said, right, okay, we need to look at X, Y, and Z, and then you come around and someone comes around and does more of a so what I can't remember the term you use, but the insights. They're actually looking in the house to identify the where that issue is. For instance, you gave the example about the plumber or whoever didn't put the insulation back correctly. Where does it lead to? And
I get you've got a few different use cases, haven't you? But if you're thinking about a retrofit, um, it's madness to think that you might spend upwards of £20,000 on insulation and improvements to a property on the grounds of energy efficiency without having a measured sort of baseline and understanding of what you're dealing with.
No, I mean that case
Um,
study, the house, or was it flat where they heat pump, they've ended up only having to buy a heat pump or install a heat pump of a certain size, not the one that was predicted.
yeah, so carrying out measurements pre-retrofit is directly informing your investment decisions. And yeah, you might decide that actually the heat loss through those walls aren't as bad as I thought, and therefore
Mm,
going to prioritize renewables. And I didn't think a heat pump was viable, but now I actually can. And so pre-retrofit, I think, is really clear of the value and use case of the measurement.
mhm.
Um, for new build, I think it is a bit more of a um, yeah, unless you're kind of being beaten with a stick to say that planning policy is saying you have to do it, or procurement, kind of the social housing providers asking for it or whatever. Um, it's an extracurricular thing of, well, as an architectural practice or as a client, um, yeah, how much value do you place on the learning? It's not necessarily going to mean that you measure and then alter things on the given delivered building, but you might then learn and it informs the next project.
Yeah,
Or
it's
that
interesting
you
because you're
identify.
at pains to point out that it's not there to beat someone over the head with, but
Mhm,
equally, if you're purchasing a new build
mhm,
and they've promised that it's, EPC rated, but it's
mhm,
not, then
yeah.
yeah, then there's a dispute there, isn't there? And yeah, I mean, it opens up a can of worms and not just a Pandora's box in terms of how you want to use it, but ultimately it is to ensure that people are delivering what they're saying they're going to do. I'm not sure about delivering on outcomes. That's an interesting concept. I think it might no one
Yeah,
would,
and
but anyway,
but we're in fact, like I said, we set up in 2016, and our formative years have been around developing and validating these different innovative techniques.
yeah,
It's early days in terms of these new techniques finding their place in the marketplace, and it's down to others to kind of yeah,
yeah.
obviously
So
regulations will evolve and build out around them, and yeah,
you've got the tools, and it's just a question of whose responsibility is it to employ them. I mean, for me, I'd love to have those little 3 weeks. You're smart. Um, um, so what would you call them? The
smart HCC.
yeah, smart HCCs around the house. I mean, I've got a fair idea what's wrong with this place, but it's just it should become common practice for me for people to then understand where they can make improvements.
Yeah, it's definitely a like you're getting at. It's kind of okay, great. I've got the measurement now. Now what?
Yeah,
What do I do with it? And it's
but
yeah,
without
it depends what
measurement,
stage you're
you're
at
not going to
and
be
what
able to know. Yeah, exactly. Yeah. No, sorry, I'm interrupting you on your summary anyway. Sorry, apologies.
no, I'll leave it at that. I think yeah, held that on the screen for a little while there anyway. So yeah, there's my contact details. Very happy to follow up with people. Hope you found that useful. And yeah, like I said at the start, it's a big subject, and done our best there to cover it
No,
in
you did.
the
Sorry,
right
when